Hello and welcome to the datasets YouTube channel. Today we are talking about the first most important topic in SQL queries, which are the select and the from statement. So stay tuned. So let us start with a quick introduction of the BigQuery frontend. Let's start here. We have two lines. We have the DWH Udemy course, which is always the exact same name as you have here. DWH Udemy course is the project name, so we also have this here as an entry. This one you would always see. Additionally, you can also have the BigQuery public data entry. And the BigQuery public data is all data which is publicly available from BigQuery, which comes from any kind of other company or whatever. And this data is available for everybody. And this DWH Udemy course is just the data we have in our project. For our tutorials, we will always use both. So we will use data in the dataset 3 DWH e-commerce. So here we have some data from a shop, for example, order item, product data, customer data, and so on. And this will be used for our tutorial. So dataset is always just like a folder for tables. And then you have always the tables, which are then these. And for BigQuery public data sets, we have to scroll a little bit. As you see, there is a lot of things going on here. And then we will come to San Francisco bike share. Yes. So here are the 3 or 4 most important tables we will also use for our tutorials. So and then here on the right side, we can write our BigQuery queries or our SQL queries. We also have different tabs here, not that important for now. So let's start right away with the first query. I will copy them from my notes and then we can quickly go through it. So that's the first query which is working. You see that it's working, that you have here a green basically, and this query will process of megabytes when it runs, which means you have to pay when you run this query because you're asking data from the database. If you need any more background knowledge or information about what is the cost structure of BigQuery, what are projects, so this one here, for example, what is an organization, and so on, let us know in the comments and we can make a video about it. So let's start. All SQL queries need select and a from statement, as you see here and here. So the select statement always defines which columns we have at the end in our table. So that means we want to have a column which is called start station name. And then we have the from. The from always comes after the select. It always need to have exactly that structure. And then we have a reference to a table. As you can remember, we had BigQuery public data. That was this one. Then we have San Francisco bike share, so separated via a dot. So we need to scroll here, and we have here San Francisco bike share. And then we have the bike share trips. So that's the table, and that's then this one. So we have project. If you just have one project access to or referencing, or you basically want to use the same project as you are currently, then you don't need the project name, but it's always safer to do it. Then you have the dataset name, that is important, and the table. So when I run this now, so you can click, you can just do it by Command and Enter, or by selecting everything in Command E, or you can just click on run. So what is it doing? Then here at the lower part, you see the query result. And here you see, okay, it shows me any kind of start station name that looks like a station or the name of the station. So now a small amount of information about the table structure. Bike share trips is one row, one trip, which means a person or a group of person starts at one station and ends at one station. On the same one or on another one. And then they give back the bike and then it's done basically. And that means we now at least that 5 trips of all time started on the 10th, 8th at E15th Street, whatever. But it could be even more. We are not sure if that is now really sorted here or not, because we didn't make any kind of order or something like that. But we could at least say, okay, at least 5 trips of all time started on that start station. Then we have here the next one, Fallon Street, and so on and so on. As we see, we have here already a lot of. And then here at the bottom, you see per page, not so important, but here you see how many rows we have. So we have 1.9 million of rows in our table. Okay, I think that was quite easy. So let's go to the next step. The next step would be to make a select distinct. We can also again run this one. For now, you need to trust me. Later, we can also prove it. Is that we have just every station name once inside. That means we have the 10th, 8th at Street. We have just once inside. Also the Fenner Street, we have just once inside. When you look at the number of rows. We have just 379 rows inside. So every start station name, every combination of columns you are setting here, currently we have just one, it's shown just also one time. We could now order it and so on. Then you will also see that there's basically just always one station name inside. But yes, so that's the idea of distinct. So always when you put the distinct in front of the, or after, immediately after the select and in front of the column names, then it says, okay, just every combination of column values, we show just one. Why I say combination? We also see it later in 1 or 2 steps. Start station name can be twice inside, but then with the second column just once, we will see it later. But for now, every column value just once inside for the start station name. So let's delete the select distinct statement again. So now we are again at these 1.9 million. And now I would like to continue with end station name. So when this is done, then we see that we have now the column start station name and we have the column end station name. And now we know every line is also one trip. So we know, okay, there was where a trip which started at the Fennett Street and ended at the 8th Street. We also have here, for example, trips which started at Fennett Street and also ended in the Fennett Street. So that's basically all the information you added now to that query. Now comes the next one. And let's see how BigQuery is doing the ordering. If you see immediately what I mean with the distinct values. Nice, as you see. So we have the end station name, 10th, 8th at Street. And we have here as well the 8th Street. So this combination, so that the start station name is 10th, 8th, and the end station name has the same name, we will just have once inside our results table. Our results table is not just anymore 380 rows or whatever it was. Now it's 27,000 rows. So we have 27 rows of different combinations of the start station name and end station name. So here we see, okay, there were a lot of start station and all of them ended at the 10th, 8th. So due to that, we can have this one doubled, 3 times inside, 4 times inside, whatever. But then if that is the case, then we have the start station name just once inside. Can be also the same for this one. So I'm pretty sure that we have, for example, this one, whatever. Then we also will have this one doubles and 3 times inside and so on. I think it's currently more sorting randomly via the end station name. We will see it later. Okay, so let's take the next one. Next one, super easy. We are deleting distinct values with the column names and we are doing a select star. Be always careful with select star in BigQuery because super quick information, but in BigQuery you're paying per column and per row you need to read for your queries. And due to that you're doing select star, you are selecting every column which exists in that table. That means you are not pre-selecting any columns. So you're paying, even if you just need 10% of the columns at the end, with at least that kind of query, you're paying for every column you requested or which is inside the table, which is maybe not the most cost efficient way you could query your data. Because what you could also do is you can go here, click on bike share trips, then you can click on preview. So here you have the schema, so which columns are inside, then some details, we can take a look later into that, and the preview. And here we have exactly that. So we have all the lines inside, no ordering at all, and all the column names where we very quickly get an idea of, okay, which data is there behind. So yes, basically what we see here, we also see here. So that's basically everything. So we just see all the columns which are available. We have any kind of trip idea, how long the trip was in seconds, the start date, start station name, and so on, end date, end station name, which bike number was there, and so on. Some further metadata, we will come to that in the later tutorial. And the last one, and here I would quickly like to switch to another table, bike share station info. So as you see, right, so that table is not existing. So BigQuery tells you, hey, I didn't found the table and so on. But when you completely writing it correctly, then it's also working. So as I will also do a select star here. This one is not that big. Here, every row is one station. So you should have here the connection between the station ID and the name, which you could now join together. For example, to get the short name in the trips table as well, comes later. And here I would like now to do, for example, the name. And when you have now a lot of so with name, I mean these ones here, right? So these names I would like to have in just one column. But when you have now a lot of tables in your query, you are referencing to each other and you are joining and so on, which we will cover later. Then you have no idea anymore what is name. Name can be a customer name, can be a region name, can be a bike name, whatever. So what I would like to do is I would say, okay, that one is the station name. So what you can do is you can type as station name. And we run this one. Then we have now exactly the content from name. We just renamed the column. Now it's station name. In the original table, it's still in bike share station info, it's still name, right? We just changed the name in our result query on our result table, which is now station name. Yes, so that's basically all the most important part. What you can also do is you can also delete the as. It's also still working. I usually like more when you also add the as, because then it's quite quickly, okay, what is the idea behind? Yes, and then the last one for the bike share data. What you can do as well is you can do as stations. So you can even give your tables, you can give aliases. So that one is still working. Still just said, okay, bike share station info, which is now station, whatever. And I just want to have the name, but I want to have that the column name is called station name, and you have your stations. What you could now do additionally is, just that you already at least heard of it, it will be getting interesting when you have a join. So when you are two tables together, because what is happening when you have two tables in the same step, but both of them have a column name, which is called name, then you have a problem. So based on that, you can say, okay, that one is station. Now I can say, I want to have the station, the name of the table station. And now still the same, but now you know, okay, that column comes exactly from the station table, which will getting interesting later. Yes, what we can quickly check is, so now we have 472 lines. And I said every station is entity. One row defines one station, which means when I now would do a select distinct station.name of as station name, I would expect that the amount of lines 472 stays like that, because every station name we have just once inside. So when we run this, let's see what happens. We have still 472 lines, which means every station name is just once inside. A good quick check you can always do when you have any kind of these entity tables, like an order table where we come now to a station table, a customer table, whatever. You always check, okay, when I have a customer name, a customer ID, especially that you're checking, okay, do I have that customer ID or do I have every customer ID just once inside? So then I will delete this, and now we don't want to query anymore the San Francisco bike share data. I want to query our shop data, our order item data. Quickly take a look inside. So we have here a lot of rows. As you see, product information with revenue. We have any kind of stock quantities. We have country information. We have channels information. We have customer information. We have an order number. We have the date of the order, and so on and so on. So we start. You also see the format there. I quickly copy the first one. So I want to have order date from DWH Udemy course. So now we are taking the data from our project, 3 DWH e-commerce, and then order item. That's the tab we want to address, and we query that. And now you see the date format of BigQuery. You see that it always starts with a year minus the month minus the date. So we are getting again a list of all the order dates we have in our data. We have at the end 1.4 million of rows inside, so a little bit less than with the trips, for example. Now we can do here the same. So for sure there will be, due to that we have more, hopefully more than one order in one day, we will have a lot of duplicates of order dates here inside. So we can do the same thing. We can do a select distinct of order date, and now we have just 891 rows. Every order date is just once inside. There's an even better way to do that. We'll come to that later with group by and count and max and sum and so on. That will come later. But for now, we just want to take a look into the distinct value or distinct functionality. So I delete that, and now we can also take the product name inside and run this. And now we have the order date, and we know, for example, that on the 26th of November 2022, the product man hoodie, whatever, was bought by somebody. And the same product was bought on the 6th of May, and so on and so on, right? So BigQuery is always doing any kind of ordering. BigQuery thinks it makes sense. Now it looks like that it's ordering via product name, but we have here different products inside with different order dates. Now we could do here again the select distinct, as we did it before already. You can add here 3, 4, 5, 6, 7 columns on it. It's always with the select distinct functionality. It always just shows every combination of the chosen columns. Just so we know that one hoodie or more was bought on the 26th of November 2022. How many we do not know, but we know that it was at least the case once. We have no list in terms of, okay, how often was it? We just know it was once because all the duplicated values we deleted. for order date and product name in combination. So then we have the select star. That one I also want to skip now. We did it already. And what we can quickly do is again the order date. For sure, also for date columns, you can do the same thing. Order created date or at. We usually use for date then date as well. And for timestamp, so where you also have the hour, the minute, the seconds attached to the value, we would call it an order created at, for example, or order created TS for order created timestamp. So now the only thing what we changed is the column name. That's it. And what else? As we did it before, you can do here also as order item, or you can also do here to test, whatever you can give it a name, whatever you like, put it here, and we change nothing. We just said, okay, I really want to have from that table, I want to have the order date. So that's it. That was the whole magic behind a select and a from statement. And with these two small functionalities, you can already build SQL queries and you can already ask things about your data in your data warehouse. So stay tuned for the next video.